everybody, welcome back boys and girls. It's your main math man, Mr. Shen, coming to you live from Walker Grant Middle School. And in this video we're going to be wrapping up some real number system notes. And this is the third video that we're doing with this. And really we're just trying to get some good closure on this so that way we can move on and prepare ourselves for that quiz. So on the front of this page, what you're going to see is just some examples and definitions. That way you can have it for your information. Again, it has those breakdowns of those subsets that we talked about, and it has that example at the bottom, that diagram that we did together, where we have the labels and those examples in there as well. However, on the back, it has some practice problems, and that's what we're mainly going to be working on in this video. And as always, some nice sweet shank style. Do not just practice until you get it right. You want to make sure that you can practice until you don't get it wrong. Again, this is a key idea because it applies to a lot of things, not just in math, but a lot of things in life. Again, if you were spelling your name wrong, or calling something not the correct name, you want to make sure that you're getting it right as well. So, moving on, we're going to say, let's see, go with this one. Alright, so on the first part, I will read the directions. So it says to circle all the numbers, number systems or subsets each value can belong to. And what I have on the side here, very simply, is that diagram, or that really shorthand picture that we can draw for yourselves. That way you can easily remember. So again, it has that RNS, that's that real number system, and it's split it into those two main subsets. We have the irrationals on the left, the rationals on the right, and then inside of the rationals is the integers, inside of the integers is the whole numbers, and inside the whole numbers is the natural numbers. So let's kind of remind ourselves what we have with those subsets. So again, it gives you a value, a real number, we should say, and you want to make sure you can circle the correct subsets that it belongs to. So you can't have more than one answer. So what we're going to do is I'm going to say, all right, for -1, is that a counting number? Not quite. So again, those counting numbers, those are going to be our natural numbers. However, is a whole number? It is not, since it is negative. However, it is an integer, and so what we can do is we can take and let's see if I can drag this over. I can. There we go. We're going to say it is an integer, and it is also a, one more time, third time's a charm, it is a rational number. So again, you can select multiples for each value, but you want to make sure they are accurate. So for the next one, it says for 568, that is going to be a counting number. That is going to be a whole number since it's positive. Again, since we already know it is a natural number, we know it is going to be all four of these choices. Again, thinking back to what you had in the previous videos as well. For the next one, it says 0.35, or you can read that as 3500ths. And if you notice that decimal place, it has values after the decimal. So what does that tell you? Well, we know that it is a rational number because it can be displayed as a ratio. And just a quick check for that, how would you display that as a ratio? Well, we would say 3500ths, you just say 35/100. So again, if you ever need to remind that for yourself, please do. So now we could say, all right, is that an integer? Well, I don't really see it on a number line, and so we're going to say no, it is not an integer. Moving on to the next one, it has 0. We're going to say that is a rational number. That is an integer, it's on the number line. And it is a whole number. However, again, make sure you're noticing the difference between the natural numbers and the whole numbers. It does include 0. However, when you start counting, you don't start with 0. And lastly, for this example, it has the square root of 2. So if you remember, is it going to be a rational number? It is not, so it is actually going to be an irrational number for that square root of 2. Again, it's that square root of prime, and so you have that there. Moving on underneath that, it says match each description with the number system it belongs to. And so again, I have those choices. I made those capital letters, that way it's a little bit easier to see. But what I'm going to do is I'm going to match those with the correct label on here. Again, if you need to, maybe, hey, I want to type in or say that this is, let's make this a little bit smaller. If I need to say, hey, instead of counting numbers, I want to put natural numbers, you certainly can do that. Again, either of those work as long as you understand what they're talking about. So again, you could say for those natural numbers, what are we talking about? Well, again, we're saying, again, on the right side, these are the subsets. On the left side, they have the description. So let's match up what we can do. All right, so for the first one, it says A. Again, you can choose any of these, but let's just start with A. We like to give alphabetical order. So it says it can include values like pi. Again, we remember that's that 3.14159, so on and so forth. It does not end. It does not repeat. So it is irrational. However, I don't see any irrational values or, subset labels on the side. However, what type of number is it? You guessed it, it is a real number. So once we use it, we're not going to use it again. And so the very next one, it says for B, it says it cannot include 0. And we know, we practice very well, the main difference between the whole numbers and the natural numbers is that the naturals do not include 0. For letter choice C, it says most basic system that includes negative. So make sure you're reading this entire thing and you want to say it does include negatives. Well, we want to say, well, we know 2 of these include negatives. However, it's talking about the smallest subset. So we're going to say it's going to be C for integers because that is the smaller of those 2 subsets. And so now I can say for letter D, it says most basic system that includes 0. We know it as the whole numbers includes 0. And last but not least, we can read through it. Even though it's a process of elimination, we want to make sure it's right. Most basic subsystem that includes fractions. Again, we're talking about those ratios or rational numbers. And lastly, at the bottom, it says circle true or false for each of these statements. Now what you want to do, anytime you have true or false, you want to say, okay, if it is false, you want to provide a counter example. And what that's saying is, hey, I know it's false because of this reasoning. So again, anytime you're in an argument or a discussion, make sure you're backing up your facts, or your statements with facts. So it says, for the first one, it says 0 can be part of the rational number system. Well, we know it's a whole number, and so we know that is true. So let me drag a circle true for that one. For the second part, it says fractions can be part of the whole number system. Well, we know that's false. Actually, let's see. Is that true? Well, let's say it says fractions can be part of the whole number system. I'm going to say that's true, and I'm going to back it up with an example. So I'm going to say, all right, for a whole number, we're saying that needs to be what? A full value. And so, well, what if I said 16 over 2? We know that is equal to 8. So again, because this is the result is a whole number, we know that is going to be true statement. So again, if you're able to come up with a example or a counter example, that way it can prove it as true, make sure you do. For the next one, it says the answer to square root of 16 can be an integer. We know that is equal to 4, and so we know this is true. Negative numbers can be part of the real number system. We know that's true. Those are integers. And then it says for the fraction 3 over 8, it cannot be part of the natural number system. We know that is false because, again, natural numbers are those counting values, and so we don't count by fractions, or we don't count by those parts. We count by those whole numbers. And it says the decimal 0.333333 can be part of the rational number system. Well, we see that it not only repeats, it does actually end, but if it did one of those two, again, if it does repeat or it does end, it is a rational number. So again, make sure you're seeing each of those ideas in there. And as always, super slam that subscribe button.